units for how long something is. William, give me one thing you wrote down.
Centimeters.
Centimeters. Love it. Matthew?
Kilometer.
Ooh, kilometers. All right. Hannah, what else? Millimeters. All right. Anything else?
Miles.
How about feet? And now these are not all of them, okay? So what is the most common unit of measure for an angle? Degrees. Okay, that's the only thing we know so far. So it says in number 3, label each sector. And I'm going to start you. And then I want you to go around the circle, labeling all the degrees around this unit circle. And then don't forget the whole way around is 360. So yesterday we did a little chanting with each other with the 45s. Remember we said 45, 135, 225, 315. I want to do that again several times. So can you say it with me? 45, 135, 225, 315. All right, everybody. 45, 135, 225, 315. Again, 45, 135, 225, 315. A little louder now. 45, 135, 225, 315. All right, so here's what I want you to do. Across here, and I want you to now use your paper circles, okay? And I want you to measure, do you see where I'm putting this in blue? And it doesn't matter where you orient your circle, but I want you to take they're called monkey string, and I want you to measure one radius, okay? Measure one radius, and I want you to cut out, I think you're gonna get 3 whole ones off of a strip. So you're gonna cut out until measure a radius, cut it with the scissors, and then I think you can get 3 whole ones out of a strip and do it with both strips. So everybody should have 2 strips, and you should have scissors. And then put your little leftovers, so do it on the second string. Did it only do exactly 3?
No, there's a little bit of leftover.
There should have been a little leftover.
Yeah, there's a little leftover for sure.
Do you see you have leftovers? I need you to,
exactly.
I need it to be exactly a radius. So you're gonna get 3 whole ones with a little bit hanging off of your last one, and that's okay. You're gonna just set that little piece aside. So you should have a total of 6 with a little left over. So when you're done, you should have 6 that are of equal length and 2 little pieces left over. Well, I'll show you what we're going to do with them. So now, here's what you're going to do, okay? And I'm going to borrow Liam's here. What I want you to do is like make a spot on your circle that is your 0 degrees and your 180, okay? It doesn't matter, I don't care how you rotate it, but make one 0 degrees and the other side 180, so that when I'm talking about, right, so you need a pencil or a pen. So write on your circle 0 and 180 to be your x-axis. So you need a pencil or a pen. So here's what I mean. If you can see the paper one I'm holding, I put 0 degrees, 180 degrees, okay? So make that your x-axis.
Wait. Is it yours?
Cal, if you flip the other way, it's the same.
So this is mine. So like facing me. Oh, you're right. No, this way. Oh, it is right. You're right. So to the right is 0, that's 180. Yeah, I was looking at it upside down. So now here's what you're going to do when you're ready. You're going to take your first whole wiki stick, monkey string, and you're going to put the one end at the 0 degrees. And I want you to wrap it around the outside of your circle like this and press it. Put the next one around, and I want to see how many whole times you can go around with your stick, your monkey string, that is equal to the length of a radius.
Isn't it like 3.14 if you use the
Oh, let's find out. That might be a good.
Oh, that's a good observation.
That's a good observation.
That's if you use the diameter.
So here's like an R length. And then here's an R length.
Mine didn't make 180.
Yeah, that's right. So there was a little
There's a little space.
space, right?
I think you made an error, probably.
No.
No, he didn't. He didn't have an error.
Sheldon made an error.
Did I make it?
Hey, guys, no comments today.
Okay.
Just following the rules.
So this is an R. See how many colors I can do. All right, so you should find that the first 3 don't quite make the semicircle. And then when you're done, you should get 6 around, and you need a little bit more to complete your circle, right? Perfect. That is actually what's happening here. So if I made it 3 times, but a little bit short, is there a number we know that's a little more than 3? Pi. Pi is your 3.14. All right. So here we go. So around, it says approximate how many degrees the angle appears to be, like one of these. So was it not quite 60 degrees? Your first,
Yeah, not quite.
not quite, okay? So it's almost 60, but not quite. So we went around and we got approximately 6 times around. But it was a little bit more than that. So here's the thing. Our radius of this circle is 1. Circumference that you learned in geometry is 2 pi r. If r equals 1, then the circumference is 2 pi times 1, or 2 pi. Each piece of monkey string is the length of the radius. So, how many pieces did it actually take? It took really 2 pi, about 6.28 to go around. But here's what we know. How many degrees does it take to go all the way around? 360. So, if you take 360 and divide it by pi, that's 57.3 degrees. This is what we call a radian. And let's make a little separate sketch here. If this is the radius and this is the radius, and the arc length is the radius, and that's what your monkey string represents, then theta, that angle, is 1 radian. So here's the big idea. 360 degrees is equal to 2 pi radians. Then that means 180 degrees is equal to pi radians. But the reason why 180 degrees is equal to pi radians is that it took 6.28 to get around the circle. So 2 pi, and so if the arc length is the radius, it takes 6.28 of those around. So 2 pi radians is equal to 360 degrees. So here's the big idea from today, but I wanted to develop what it was. A radian is equal to the angle measure made when the angle opens 1 radius. Again, if this is r and this is r, theta is 1 radian. To convert degrees to radians, you're going to take the degree measure times pi over 180 degrees. Now that we're going to introduce another angle measurement, so just like we had feet and miles, or meters, kilometers, those all measure how long something is. So degrees measure an angle of rotation. A radian is a different unit that still measures the angle. And in trigonometry, it's overwhelmingly in radians. So we started with what you knew with degrees. And now we're going to move to radians. And so the nice thing is, we're just going to learn how to convert from degrees to radians, and then we're going to go circle back, pun intended, and we're going to go back through everything we did with degrees. Coterminal angles, reference angles, and evaluating trig functions in radians. To convert radians to degrees, you're going to take radians times 180 over pi. Something I need to mention, if in degrees, you must have degree symbol. If you don't, it is assumed radians. So we don't typically write out 2 pi radians. 2 pi is implied radians. And so all I do, like when I'm doing these conversions, and so whatever science class you've been in, this will help you in your science class as well. Like if you're trying to go from like feet per second to miles per hour. So if I want miles, I put the miles over the feet so that the feet cancel. So that's going to be true. So I don't memorize this. I just know that pi is equal to 180 degrees. And whichever answer I want, if I want degrees, then 180 degrees goes on top over pi. If I want radians, then the pi goes on top over the 180. So in number 1, it says convert the radian measures to degrees. So you're going to take 3 pi over 4 times. I want this in degrees. So what goes on the top of my conversion fraction?
180.
180. If it's unit circle, these are going to turn out to be 30 degree, 45, or 60 multiples, okay? So here's the deal. The pi cancels. And I want you to, don't touch a calculator, okay? We should be able to do this without a calculator. And even though at first it seems like, whoa, how am I supposed to do that? Well, if I start with, instead of 4, what if I start with 2? How many 2s are in 180? 90, right? Okay, there's 2 sets of 90. Well, then if I want to have another pair, I would divide 90 by 2. So there are 4 sets of 45. Okay, because 45 and 45 is 90. And then another 45 and 45 is another 90. So this one's going to reduce down to 4. And I'm going to get, now that's 40, right? 45, sorry. 45. So 4 goes in there 45 times. 3 times 45, hey, 45, 135, 225, and 315, that's my 135. So practice the mental math. So let's try B. 3 pi times, I want degrees. So I'm going to multiply by 180 over pi. The pi's cancel. So that's 540 degrees. All right, the third one. 13 pi over 6. Yay, the pi's cancel. But then you want to ask yourself, don't multiply and then try to divide by 6, because sometimes you might be asked to do this without a calculator. So, see if how many times will 6 go into 18? 3. So that's going to be 30. And so 13 times 30, you can just stick that 0 over. So that's 390 degrees. All right, convert degrees to radians. So you're going to multiply now by pi over 180. So go ahead and do that with all 3. All right, so 45 goes in there 4 times. Did you get pi over 4?
Yep.
All right, 315 degrees times pi over 180. So do you see with 315, that's a multiple of 45. Okay, the 315 is a multiple of 45. So I want you to try to do these without a calculator. You should begin to remember that 45 goes into 180 4 times. So then 315 is almost the full time around. How short is it from making the full rotation? 45. And if you notice, in part A, I did 45 degrees, and that was pi over 4. How far is a full rotation in radians? We did our discovery, remember? What's a full rotation? 360, but in radians, how many was it? 2 pi, right? It was 2 pi radians. So if I'm 45 degrees shy of a full rotation, so stop and think about this. I am a pi over 4 shy. Couldn't I, this would be another way to think of it, isn't that 7 pi over 4 then? Or you can reduce that it goes in there 7 times. You can have angles that are positive or negative. So if in letter C I have negative 120, I'm going to still multiply by pi over 180. All right, 120 and 180, what's the biggest common factor they have? 60. 60 goes in there 3 times, 60 goes in there negative 2 times. That's negative 2 pi over 3. All right, here's what I want you to do. I want you to first go around this circle and label it with degrees, just like we did earlier. So then that's what, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and a full way around is 360. Now what we're going to do is we're going to go around and put the radians. And what I want to do is I want to do these by reference angle. Okay, so if I have 30 degrees, that's times pi over 180. 30 goes into 180 how many times? 6. So this is pi over 6. Now, if this is pi, okay, 180 is pi, and I'm 1 pi over 6 away, isn't that 6 pi over 6 minus pi over 6? That makes 150 5 pi over 6. So do you know when you were learning a language, maybe you're in Spanish, and then when you get far enough advanced in a language, you can begin to think in that language. So we want to learn to think in radians. I know this is our first day, so that's not going to happen, but do you see 30 degrees is pi over 6? Do you understand that 150 is 5 times that?
Yeah.
Oh, that's 5 pi over 6. Okay, so then what do you think 210 is? Without even doing a conversion.
7 pi.
Yes, 7 pi over 6. Then let's jump around to the 330. How many sets of 30 is in 330? 11 pi over 6. All right, beautiful, beautiful. Now, let's do 60. If I do 60 times pi over 180, what does that reduce to? Pi over 3. So now let's use the shortcut. If 60 is pi over 3, how many sets of 60 are in 120? 2. It's 2 pi over 3. Let's jump down to 240, because that's a 60-degree reference angle. 240 is how many multiples of 60? 4. That's 4 pi over 3, because I have 4 sets of pi over 3. Then let's go to 300. And the reason why I'm going to 240, 120, and 300 is those are 60 degrees away, okay? So 300 is how many sets of 60? 5. That's 5 pi over 3. You don't have to memorize these. You can figure them out. And then up in letter A, in number 2, do you see that we did pi over 4 is 45? Now watch how you're going to do these. The 45s are cool. So do you see this is pi over 4. This is 2 pi over 4. What's 2 pi over 4? Half pi or pi over 2. So let's write that one down while we're there. That's pi over 2. If we go around again, do you understand that's 3 pi over 4? Here I have 4 pi over 4, which is pi. This one's 5 pi over 4. I have 6 pi over 4, but we never leave them unreduced, so that's 3 pi over 2. And this is 7 pi over 4. This one's 8 pi over 4, or 2 pi.